Alright, ladies and gentlemen, I am going to try to break this up into parts. So if you just watch part 1, hopefully you have made your way onto part 2, and we're going to be taking a look at I understand and can use Coulombs Law, the formula. So to develop the formula in class, what we did was we looked at everyone's slope and how that related to QR and QG. For groups that had a slope of 3, and they had 1 and 3, let's say. If they had QR and QG of 2 and 2, their slope was 4, and we saw if you had a whole bunch of 1s, your slope should have been about 1. And you realize, after looking at more of this data, the slope in this case is equal to QR times QG. So the two numbers multiply. 3 times 1 is 3, 2 times 2 is 4. And from this, you can actually create, we'll use that in a second in that upper right hand corner, you can actually create a very nice mathematical model. So when we look at this graph, we get that the slope is equal to the q's multiplied together. Whether it's 1 and 2 or r and g, it really doesn't matter. And then, as we can see on over here, you notice the y-intercept is 0. And what we can do is we could say FEL is equal to m, which is q1 times q2, all over r squared. But then there was an issue with this. When Coulomb was studying this, when you actually do this with charges, you'll notice that there is this k value. You notice there is a factor that it was off by, where it was actually k times q1 over q2 over r squared, and k is going to be the Coulomb's constant. So in this case, k is Coulomb's constant, which is equal to 9 times 10 to the 9th. And the units on here, to make sure everything works out really nicely, it is a Newton meter squared over what they call c squared. We're going to talk about c in a second, because when you start looking at this q1 and q2, q represents the amount of charge. Amount of charge is the unit that we measure amount of charge in is actually a coulomb. We'll talk more about conversion factors for coulombs. Coulombs are equivalent, or there's a conversion factor that you could look at in terms of electrons. Coulombs go more towards understanding electricity. That's actually where a coulomb is defined. We are not there yet. It deals with charge flow. So we can't necessarily define it yet, but I'll give you a conversion factor on what that is. So again, the unit for charge flow, or the unit for the amount of charge, is a coulomb. And so, and of course we have r, which is the distance apart, and as you can see in Coulomb's constant, the meters here, which means, guess what, our unit for this has to be in meters if we want that to all work out nice and neat. And FEL is again our electrostatic force. A lot of people ask, what force are we solving for here? Well, this is actually the force between the charges. And remember, if you solve for this force, if you solve for the force on 1 by 2, that's technically the same as the one on 2 by 1, thanks to good old Newton's third. So you can always go back to that. This is actually both forces. It's technically the same force. So taking a look at this, this is our nice formula. This is our new formula. It has a lot of terms in it, but once you get using the terms and you feel comfortable with it, it should go by pretty quickly. So going back on over here, you could see that I understand and can use Coulomb's law. We got the understanding, we got the idea of the terms, the units, what it represents. We should be able to pull that together. In our final portion, I can solve Coulomb's law problems. So this is going to be what is going to take us to tomorrow. I guess I got to kind of move down here a little bit. Coulomb's law problems. What starts to happen is you might run into a case where you have 3 charges just kind of hanging out in space. You're going to see, they might call it Q1, Q2, and Q3. And in this case, a lot of the times with Coulomb's law problems, it might ask, what's the force? Or the net force on Q2? Key things to think about with Coulomb's law problems. Number one is if they don't give you masses, technically you can ignore the mass. Fg is usually really small when dealing with charges, especially protons, where that Fg is not going to play a factor. Other factors is we're really just focusing on the electrostatic forces here, and those gravitational forces are not going to play a factor. So whenever I get a question like this, I need to resort to the things that I know. And of course, I would draw a force diagram. So in this case, I would go FEL on 2 by 1. And you'll notice how I drew this. I drew this down because guess what? That's going to be a repulsion from 1 to 2. And the other thing, by drawing my force diagram, I'm looking at this 2 is going to be affected by 3 as well. So I would draw that in here, FEL on 2 by 3. And you'll notice I have these two force values. And, hey, wait a minute, where'd we go? There we go. I have these two force values, and it's like, wait a minute, I want to calculate this. And of course, the question is that you should probably be asking is how do you calculate this? Well, hopefully in the problem, they give you the good old stuff that we know or anything else. We're looking for Q1 or Q2 all over r squared. So you're trying to figure out FEL. You know K, that's a constant in any given place. K actually represents, it's the constant in free space. That is the only one that we're going to use in this class. But depending on where you go, that constant may change. Q1 is going to be the amount of charge that's going to be given. Q2 is going to be that. And of course, r squared is going to be the distance between the two, which if I go back to my picture will be this distance here. And hopefully they'll give you some coordinates or things to work with in order to get that. So Coulomb's law problems really consist, if you go back to our idea here, we have the force diagram, ignoring gravity unless if masses are given to you, and then using our new mathematical model and just kind of plugging and chugging and knowing all of those values as we go. So going back to here, you can see that we've wrapped this up. This is part 2 of the idea. We wrapped up 2 and 3. I can solve Coulomb's law problems. I kind of gave you an idea what to look for. Tomorrow in class we will finish up, or we will start worksheet number 1. It has a whole bunch of good problems with Coulomb's law as well as other factors. Thanks for listening. If you have any questions, please make sure you've written those down or listen over this again. I'm more than happy to cover those in class tomorrow. Have a good night.